Good evening, ladies and gentlemen. Welcome to your National Museum of American History. I hope you're enjoying the evening, and we're here to celebrate LaserFest, the 50th anniversary of the laser. And this innovation has launched many memorable applications in a wide array of fields, as all of you know. And now, today, lasers are everywhere. We recently reopened the museum after a 2-year renovation. We opened in November 2008, and since that time, we've had more than 5 million people visit the museum. They come from all over the country and from around the world, and they come to this museum to, as I said, try to understand what it means to be an American. So it's very important that we provide a critical link between the past and the present. And I'd like to say that at the American History Museum, we're shining new light on American history. And so this special 50th anniversary year gives us an opportunity to shine the light on the great scientific achievements that have occurred around the world associated with laser technology. And now, I'd like you to enjoy the rest of your evening. Thank you so much for being at your National Museum of American History. Thank you.
Ladies and gentlemen, please welcome Tom Baer, Executive Director of the Stanford Photonics Research Center.
Good evening. Good evening. The perils of Facebook. Well, good evening. Welcome to LaserFest at the Smithsonian. It is altogether fitting and proper that we are gathered at the National Museum of American History to celebrate and honor the original laser pioneers and researchers. Without their work, technologies we depend upon today would not exist. 50 years after the first demonstration, lasers power the internet, scan our groceries, play our CD-ROMs and DVDs, guide airplanes. Lasers have enabled Moore's Law, Bose-Einstein condensation, and the sequencing of the human genome. Based on the efforts of these early pioneers, extraordinary advances in almost every field of science continue to accelerate even today. Many great minds brought the concept of the laser to fruition and made possible its first reduction to practice. That pivotal event occurred in 1960 at Hughes Research Labs in California. There, Ted Maiman demonstrated the first man-made source of visible, coherent light, the laser.
How sophisticated is this, is the question?
Well, this is literally the first laser. This is it, ever, right. This is it, and the beam emanates, a red beam emanates right from the end of this.
Okay.
But it's pretty simple in construction. Here are the parts. There's really 3 parts.
Okay, here's the first part. What can this laser do, this basic laser? We can't plug it in because we may put Shaw TV off the air, but...
Well, I think you took away one of my props. But
did I?
Anyway, if you put a lens in front of it, it's sort of startling if we actually did that and focus the beam onto a razor blade. It'll drill a hole in it. And
in the razor blade.
In the razor blade. And in the early days when people start making lasers and they start making ruby lasers, which was, as I said, the first laser, all of the lasers that people made for a while were ruby lasers. And everybody tried to make them more powerful than another, and they brag and they'd say, I have an 8 Gillette razor. What's an 8 laser? What's an 8 Gillette laser? It's one that can bore a hole through 8 razor blades in one shot. This is a 1 Gillette laser.
A 1 Gillette laser.
Right.
Okay, this is good. You could go on TV with that if you can say it. A 1 Gillette laser. Okay.
Well, an 8 Gillette laser. Obviously, Schick and Wilkinson missed a major marketing opportunity. Well, back in 1960, many brilliant scientists and engineers were racing to demonstrate the first laser. In the next video, Boris Stoichev, a much respected, and I must add, a much loved early laser researcher, reminisces with Paul Kelly over his own unsuccessful attempt to make the first laser.
During the latter years, sort of 56, 57, 58, my friend Art Shallow, who was working with Charlie Towns by then at Columbia University, they were writing this book on microwave spectroscopy. And so he would send me chapters as they wrote them, and I knew about their work. Then they had this idea of the laser. Of course, at that time, it was called the optical maser, or this is what they called it. Charlie Towns, of course, with his with Jim Gordon and Herb Zeiger, had developed the maser, the microwave unit. And so now in '58, Art and Charlie, and Charles Towns, were thinking about the laser in the optical, the infrared region. And Art kept me informed about what was going on. So I immediately dropped all my work in Raman's scattering and decided I'm going to try and make the first laser with using mercury excitation, atomic mercury excitation.
Well, Boris's story clearly illustrates the collegiality and the generous sharing of information and resources that characterize scientists at their very best. Boris goes on to say in that video that he actually saw gain in his laser, and if he had had Brewster windows to reduce the losses, he probably would have won the race. Please welcome Secretary of Energy, Stephen Chu.
Thank you, Tom. Thank you. It's a pleasure to be here. My talk is a little long, so I'll skip the formalities, look at the blinking lights, and start. I will just conclude by saying happy 50th birthday. Thank you.
I'd now like to introduce my friend and colleague, Professor Anthony Siegman. I've known Tony for most of his 40-year career at Stanford University. Tony is recognized internationally for his numerous contributions to microwave and quantum electronics, laser physics and devices, and optics. He is well known as one of the world's foremost laser experts. I'd like to introduce Tony Siegman.
If you believe it, my wife married me with that beard. Thank you, Tom. It's a great pleasure and honor to be here with you and all of the scientists and researchers who have contributed to this transformative and immensely productive technology. As a first thing, I want to introduce our next video segment. This one features Ali Javan, a distinguished laser pioneer from Bell Labs originally and now MIT, discussing the challenges and the eventual applications of the helium neon gas laser, which Ali invented in the late 1950s and made work, and which was one of the first early lasers that would go on to have numerous applications.
But there are other gas lasers. That it's in my patent actually at the time. Other gas lasers that operate in all sort of color. You know, this argon laser, for instance, is one of the follow-on lasers that was made by another beautiful colleague at Bell Telephone Laboratories, the one that you see in light shows. You see this blue light and all. But those came out. Scientific use of it was of foremost interest, I must say. and much of the early experiments and all, but it was a helium neon laser for communication, transmission of signal. As a matter of fact, I can also tell you that the very first transmission of voice on a beam of light took place the really next day, and the telephone rang at 10 o'clock in the morning. You know, I was stayed up all night, and I pick up the phone. I see there's this voice saying, "Mr. Watson, come here." You know, this is that story of Watson, come here, I need you. And it turned out that one of my colleagues they were transmitting voice across the same helium neon laser across a huge laboratory, picking it up, and it was telephone conversation with laser link. You see, the laser link that took place right away, and that was the interest and use of it in communication.
As essentially the very nearly the last segment of our presentation this evening, I'd now like to show you a slideshow which will salute several of the early laser pioneers and the notable laser researchers who are here in attendance tonight. And I'd ask that you, as we go through this, you please hold your applause until the end of this collection of slides, and then we'll ask these people to stand up and receive your recognition. So the first name is someone we had hoped would be here tonight, but was unable to attend. But we certainly wish to mention Charles Townes, who received the Nobel Prize in 1964, as you've already heard, for his fundamental work in the field of quantum electronics, which led to the construction first of microwave and then of optical frequency oscillators and amplifiers based on the Maser laser principle. And this included the very first man-made stimulated emission device, his ammonia maser, which you've already heard about in the early 1950s. Dr. Townes' long and distinguished career also extended broadly into other areas of basic science and especially into public service. Now, the second name is James Gordon, Jim Gordon, who as a graduate student worked with Charles Townes to construct this first ammonia maser, and then during a long and distinguished career at the Bell Telephone Laboratories made many fundamental contributions to laser physics and to optical communications. A third name is Nicholas, that you've already heard, is Nicholas Bloembergen, who first invented an important early microwave solid-state maser that stimulated many of us to move into this field, and then subsequently received the Nobel Prize for very widely hailed fundamental contributions to nonlinear optics and to the development of laser spectroscopy. Also here with us this evening is Victor Evtihov, who, as a member of Mayman's team at HRL, made some crucial measurements and on Ruby and co-authored several of the early publications on the Ruby laser from the HRL group, and who was subsequently responsible for many additional advances in laser technology and laser applications. As you've just heard, Ali Javan, whom we're delighted to see here with us also this evening, working in the Bell Telephone Laboratories during the late 1950s, conceived and explored the basic concept of laser systems using gas discharges, and then brought this concept to fruition by operating the first successful gas laser, the well-known and widely used helium neon laser. Also with us is Kumar Patel, who just a few years afterwards, also working at Bell Labs, invented many different gas lasers, including particularly the carbon dioxide laser, CO2 laser, which was the first gas laser to produce the kind of continuous power that you needed for industrially significant metal and other metal cutting and other applications of high power laser radiation, and which remains a workhorse of the field today. Also with us is Elsa Garmeyer, who, as a graduate student working with Charles Townes at MIT, first demonstrated important nonlinear effects produced by these powerful beams acting on atoms and molecules that were scientifically very interesting things that you could do besides drilling holes in razor blades. And Elsa went on to have a long and distinguished career as an educator and a leader in her profession. We also have Daniel Kleppner, who, as a graduate student, I believe at Harvard University, collaborated in the development of the hydrogen maser, which was a third type of maser that started on this path to extraordinarily stable atomic clocks and atomic wavelength standards. Finally, among these early pioneers, we have Ting-Yi Lee, who during a long career at Bell Laboratories collaborated first in developing crucial early understanding of laser resonators and their modes, the mirrors part of laser physics as distinguished from the atom part, and then subsequently made remarkably important contributions to the development of laser communications through optical fibers, the technology, as you all know, that weaves together the World Wide Web and makes possible the internet we have today. We've just heard from, to our delight, from Stephen Chu, the Nobel laureate and current US Secretary of Energy, who showed us that he not only developed methods to cool, trap, and position atoms with laser light, but is apparently still doing so. And as another, we have also Roy Glauber, who received the Nobel Prize a few years ago for his fundamental and widely used theoretical contributions to the quantum theory of optical coherence and the basic theory and understanding of laser physics. Then Jan Hall from Boulder, Nobel laureate for his, it sometimes seems, unending contributions to the development of new methods of laser-based precision spectroscopy and precision measurement, including the optical frequency comb technique. Finally, William Phillips, a Nobel laureate who developed methods to cool and trap atoms with laser light, and who today serves our nation through his scientific creativity and his scientific leadership at NIST. So may I ask those of you whom I have just named to please stand for a few minutes with your spouses and companions and family members you may have with you, and we'll offer a Thank you again to all of these special guests for being here. It's wonderful to see so many of them again. Your contributions to the field are truly inspiring and have laid the foundation for the next 50 years of laser innovation. Now, as we all realize, much of your work was supported by federal funding agencies of various sorts. And we would just, these agencies also deserve a round of applause for the innovations past and present that they have made possible, and we hope will continue to make possible for years to come. So thank you all for these. So, coming close to the end, when Charles Townes and Arthur Shallow published their analysis predicting the first optical, or predicting how to make an optical maser in 1958, and organized the famous Shawanga Lodge Conference in 1959. They perhaps did not really understand in full the impact such a device would have in so many areas of our lives. And as you heard earlier, the laser was referred to, I have to say rather foolishly, it seems to me, as a solution looking for a problem. And of course, today, the laser has proven to be much more than a simple solution to a problem or a few problems. It's really a critical technology, a critical component in countless scientific fields and technologies, enabling, in many cases, whole new fields of research and whole new fields of useful technology to emerge. And just as a final bit of inspiration, we'd like to leave you tonight with the words, with just a few words from Charles Towns on that theme.
Science is fun. Finding new things is fun. I've just had a good time all my life, and I encourage you to think about things, explore things, and find new things. It's great fun, and it's very important for humans.
So on behalf of the founding partners of LaserFest, and I can tell you that those founding societies have been working immensely hard all through this past week, and especially hard all through this somewhat difficult evening. I thank you all for attending, and the script here says that the reception begins now upstairs in Flag Hall, but I'm not sure what you might find up there. But thank you all for attending, and welcome to it.